and welcome, and in this video we are going to talk about solving rational equations. Now, when we're solving rational equations, we're going to be using something called clearing the fractions, and that's going to require you to be able to correctly identify what the least common denominator of a rational expression or expressions is. So if you haven't watched my video on adding and subtracting rational expressions, make sure you go back and do so. If not, let's jump right in. So, I want to start by covering a fairly easy problem, one that you probably have actually already seen before in Algebra 1. A rational equation such as this. It's almost like a simple proportion problem, right? Because we have a single fraction equal to a single fraction. Now, when you were taught how to solve this, you were probably taught, hey, you should cross multiply, right? You multiply one numerator to the other denominator, and you do the same thing with the other one. You set them equal, and you solve, right? Now, this is correct, and I would do this, but that's not actually what's happening behind the scenes. And I kind of want to explain to you what's actually going on, because it's going to make these more complicated and more challenging rational equations make a lot more sense. I don't like you guys just knowing tricks without actually knowing what's happening. Because if you just know a bunch of tricks, do you really know what you're doing? So, what's actually happening behind the scenes is you're actually finding the least common denominator of all of your fractions. And that would be a 2x plus 5 and an 11x plus 8. And what you're actually doing is you're multiplying each side of the equation, both sides of the equation, through that least common denominator. And what ends up happening is when you multiply each side by the least common denominator, this is known as clearing the fractions, because as you can see, the 2x plus 5s would cancel here, and the x plus 8s would cancel here, which would leave us with that very expression. 11x plus 8 is equal to x times 2x plus 5. And then from there, you would go ahead and solve. Right? You would distribute, you'd get everything on one side of the equation, and in this particular case, you would solve by factoring, which I'm not going to necessarily go over in great detail since it's something that we've done so many times before, but you would solve by factoring in this particular problem, and boom, you get your two answers of 4 and -1. Now, that's actually what's happening behind the scenes, and if you just did cross multiplication, you would get the exact same answer. Yes, it would be a little bit quicker, but do you really know what's happening? Probably not. So now I want to show you how this is applied in a more complicated problem. So let's go ahead and take a look at our next example, and we'll kind of go through step by step how to do it. Okay, so let's say we have a example such as this. Now notice this isn't a single fraction equal to a single fraction. So cross multiplying is completely out of the way. We can't do it. That's only possible when you have a single fraction equal to a single fraction. As soon as we introduce more, you can't do that. So what do we do? Well, we're actually going to be clearing the fractions once again. And in order to do that, the first thing you have to do is you have to factor every denominator you possibly can and simplify if possible. What I mean by that is if you factor your denominators, and if you notice in one of the fractions, one of the factors cancel it out. It's going to make your life a lot easier. So I would end up factoring, and the only denominator I can factor is x squared minus 9, and that gets me this particular equation here. Notice nothing cancels. From there, what we need to do is we actually need to now multiply both sides by the least common denominator of every single fraction. This is known as clearing the fractions because it's actually going to cancel them all out the exact same way we saw in the previous problem. So what I would go ahead and do is I would figure out what that least common denominator would be. Well, if I'm looking, I definitely need an x minus 3, and I definitely need an x plus 3, and notice this one already has both, so that would be our least common denominator, a single x plus 3 and a single factor of x minus 3, and I would multiply both sides through by that least common denominator. And the reason I'm able to do that is because I got an equation. I got two sides. I can balance it. I can do anything I want to one side of the equation as long as I do the exact same thing to the other side. That's known as balancing the equation. So I multiply everything through by that least common denominator. Now in this particular step, you might not need to show this work. I'm going to show it just to really help you visually see what's happening here. But if you're able to recognize what's going to cancel out without showing this step, totally do that. That's fine. That's personally how I do it. But if you aren't able to recognize what cancels out, do this step. It makes it so much easier. And from here, we should be able to see that, hey, these x minus 3s are going to cancel here. These x plus 3s and x minus 3s are going to cancel here. And these x plus 3s are going to cancel here. So we can go ahead and cancel out all of those factors, and notice what happens. It gets rid of every denominator. It gets rid of all the fractions, hence clearing the fractions. So what we're left with is now 6 times x plus 3 that was left in this first fraction equals all that's left in the second fraction is this 8x squared. Everything else canceled, minus 4x and an x minus 3. That's all that was left in the third fraction. And from there, we go ahead and we solve for our variable, whether it be x, y, a, b, r, who cares? We solve for that variable. Now, once again, I'm not going to go through step by step because you should probably know by now that you would have to get everything on one side and either solve by factoring, completing the square, quadratic formula, whichever you prefer, okay? But I went ahead and solved by factoring, and that got me 2 answers of 3/2 and -3. Now, there's actually one extra step that we have to cover, which we didn't in the previous problem. And we probably should have, but it was okay in that particular one. Now, remember, we're dealing with rational expressions here, and when we were dealing with rational expressions, we always had domain restrictions, right? We couldn't divide by 0. And because there were domain restrictions, that means once we get to these equations, we could have extraneous solutions. So what we need to do now is we need to check for extraneous solutions. Now, the most common case or the most common cause of an extraneous solution is actually when one of your solutions makes one or all or some of the denominators equal to 0, which means we'd be dividing by 0, which we cannot do. Now, that is the majority of the time you will get an extraneous solution. But it's always probably a good idea to double check all of your work just to make sure it all checks out. But what I'm going to do is I'm going to realize, hey, we had a denominator of x minus 3 and x plus 3, so I notice that my domain restrictions are x cannot equal 3 or -3, right? Because if x was 3 or -3, it would make 2 of the fractions denominators equal to 0, which I cannot have, right? I can't divide by 0. Well, look at one of my answers. One of my answers is -3, but I'm saying, wait, x can't be -3. There's your extraneous solution. Okay, so we get rid of the extraneous solution, we keep the answer that actually works. So although we got 2 possible solutions, 3/2 is actually the only solution. -3 is known as the extraneous solution. So we get rid of the extraneous one, we keep the good one, and that would be our final answer. Always make sure you check for extraneous solutions. It is very important to do so. Now, hypothetically, let's say you get multiple answers and all of them are extraneous. None of them work. What do you do? Well, that means you stumbled across a case that's no solution. Okay, that is possible. Say you get a bunch of answers, none of them actually work. That's no solution. So just be on the lookout for that as well. Now, that's about as complicated as most of them get. Let's take a look at one more example to make sure we're all on the same page. All right, let's take a look at this last example. We have 6x over x plus 4 is equal to 2x plus 2 divided by x minus 1. Well, what's our first step? Well, we factor, but there's really nothing to factor. Yes, you could technically factor the 2 out of this numerator here and get 2 times the quantity of x plus 1, but it's not actually necessary, one, because it's in the numerator. It's not going to help us figure out what the least common denominator is. The other reason is, well, nothing would actually cancel out. We'd have to multiply that right back out. If it makes you feel better, do it, okay? If not, leave it alone. So what we should do is figure out what our least common denominator would be, and that would be an x plus 4 and an x minus 1. Now, don't freak out about this 4. You can think about this 4 as 4 over 1, which doesn't change what your least common denominator is, but if it helps you, go ahead and do so. But our least common denominator would be an x plus 4 from our first fraction and an x minus 1 from our third fraction. So I would multiply each side through by that least common denominator. And remember, this is known as clearing the fraction because all of our fractions are going to end up disappearing because so many things are going to cancel. If I look at this first fraction, notice the x plus 4's cancel. I don't really have a fraction here, so nothing cancels over there. But notice in this third fraction, I shouldn't call it the third fraction. I should call it the other fraction. In this other fraction, the x minus 1s are going to end up canceling. So notice we cancel those out, and we now have an equation that we can solve using our traditional means. Now this one's going to be a little bit more hairy because there's a lot of multiplying and combining like terms to do. So I would go ahead and I would start by multiplying this all out. I would multiply out a little bit more, combine some like terms, right? And now if you notice, I have quadratic terms on both sides, so that means I'm going to have to get everything on one side and solve by factoring, quadratic formula, complete in the square, whichever you prefer. I like to factor, so I'm going to go ahead and get everything on one side. And I just noticed that there's a common factor of 4. I divided each side by 4. You can factor this as is. It's just going to be miserable. That's just something that comes with a lot of practice. So I get a much more simplified equation here that I can quickly solve by factoring, and I get my solutions of -3/2 and +2. But wait, we got to check for extraneous solutions. Remember, that generally comes from a solution being one of the domain restrictions. Well, if I look at what my denominators were, or I can just look at what my least common denominator was, I can see that x could not be equal to -4 or +1. Well, that's okay. I didn't get either of those as a solution. So what that means is that we don't have any extraneous solutions, and -3/2 and 2 are both going to work. And you can verify this by actually plugging it in for x and seeing that both sides equal one another, which they would for both of these. But if you're lazy like me, just go ahead and check to see if it makes any of your denominators equal to 0. That's generally where you're going to get your extraneous solutions. And that's solving rational equations, right? Not too bad, not too bad. I hope this video was helpful. If there's any questions, please feel free to reach out and let me know. Otherwise, I look forward to seeing you guys in the next video.